Today I'll explain two core concepts of semiconductor devices, the conduction and valence bands. These two are the form of energy bands, and energy bands are basically the cluster of molecular orbitals. Uh, the molecular orbitals are when two atomic orbitals come together, they split, uh, creating these molecular orbitals, and the cluster of those are energy bands. So those energy bands can also be the valence and conduction bands. The valence bands in definition are fully occupied energy level by electrons at 0 Kelvin, and the upper conduction band are fully empty energy level at 0 Kelvin. At 0 Kelvin, the electrons don't move, so if we crank up the temperature, you can see the red line. The electrons move to band to band. Electrons will move to the upper band. Okay. You can see that none of the electrons tend to stay in these gaps, which, so to speak, this is called electronic band gap. As we know in nature, the inner electrons can move freely, but also the new electrons can come in, like guests. So new electrons can come into the material, uh, and the level of the friendliness of the material is called the electron affinity. Finally, you can know that kind of like in a house, something can come in, but something can also come out. So when when the material gains some kind of energy, the electrons can come out. That in definition is ionization. So we call this kind of energy ionization energy. You can see that the electrons start a valence band to the outer vacuum energy. Um, so finally, if we subtract the electronic affinity minus the ionization energy, we can get the value of electronic band gap. Thank you for listening. This is Myung Kim of class number 3.